Hi everybody, this video is going to be about the composition of functions, and I have some background noise here, so I'm sorry about that. Today I have some construction going on outside of my window, so I'm hoping you can hear me despite that. A composition of functions is when you take one function and insert another function inside of your first function. So here you have two functions, the f, which is 7x plus 4, it's a linear function. And if you recall, the domain of this function is all real numbers, or we can say negative infinity to infinity. And you have this g of x, which is a square root function. And for the square root function, remember, whatever is under the radical has to be greater than or equal to 0. Okay, so we got the domains of the two original functions, and now I will show you how to find the composition of f with g. Now, do not confuse the composition, which is this open circle, with the product of two functions, which is where you only have a closed circle. To find the composition of f with g, you're going to treat your function f, the one that comes first, as, so to speak, the base function. And what you'll do is you'll remove the x from that function. Oh, that's loud. So this x, you remove from f, and in place of that x, you take the entire function g and replace that x with the entire function g. So here's what you're going to have. 7 stays. This used to be an x. Now in place of x, you have the square root of x, because that's the entire function g, plus 4. And that's it. Sometimes the question will ask you to not just find the composition, but also find the value of that composition at a specific point. Let's say f composition was g at 4. What you're doing here is taking the composition expression, which is 7 square root of x plus 4, and now replacing that x with 4. So take that, place it here, and you'll have 7 square root of 4 plus 4, and then you just simplify it. So square root of 4 is 2, which means 7 times 2 plus 4, or 14 plus 4, which is 18. So the domain, remember, is the restrictions that you place on the variable inside of your function. And normally the functions that do have restrictions are fractions, which means rational functions, and square root functions. With a fraction, you shouldn't have a 0 in the denominator, and with a square root function, you shouldn't have anything that's less than 0 under the square root, otherwise it becomes imaginary or complex. So we're going to look at our function here, f with g, and see if we have any of those things that may potentially place restrictions on x. And we do. We have a square root. Under the square root you have x, so you have to state, it's really loud. So under the square root you have an x, so you have to say x is greater than or equal to 0, because whatever is under the square root in your composition has to be greater than or equal to 0. And then you need to combine it with the domain of the second function in the composition. So the second function in the composition is g, and x is greater than or equal to 0 was the domain of g. So you have to combine the domain of the overall composition with the domain of the second function inside of the composition, and they actually are the same. If you look here, x is greater than or equal to 0 and x is greater than or equal to 0. So that will be the domain of your composition. X is greater than or equal to 0. Or we say from 0 to infinity. So now I would like to find the opposite composition, meaning I will reverse f and g. So the functions will stay exactly the same as before, but the composition will say g composed with f instead of f composed with g. Let's see how that will be different. We're going to take our function g now, because that comes first. Whatever comes first as the base function, that's the one that we're going to operate on. And in place of x in function g, we will insert the entire function f. So everything else will stay. So we have square root symbol, and then in place of x, we write 7x plus 4. And that's it. Now we need to find the domain of this composition, and what we will do first is find the domain of the composition, and then we will adjust it based on the domain of the second function, which would be function f. So this composition will have restrictions on its domain because it has the square root symbol inside of it, and whatever is under the square root should not be less than 0. It always is greater than or equal to 0. So I will take what's inside of the square root, which is 7x plus 4, and say that it has to be greater than or equal to 0. This is a simple linear inequality. I will solve it by subtracting 4 and then dividing by 7. So x is greater than or equal to negative 4 over 7. We will now need to combine this domain with the domain of the second function inside of our composition, which was function f. The domain of function f was all real numbers, negative infinity to infinity, had no restrictions. So this domain is way more strict than the negative infinity to infinity. So this is the domain of the composition. So the domain is in interval notation, starting at negative 4 over 7 and going to positive infinity. Okay, let's now look at another example. We have these two new functions. Each one is a rational function, meaning it has a fraction. In the denominator, you have an x inside of that fraction. So we need to find the composition f with g and then g with f and the domain of each composition. But to be able to find the domain of the composition, I have to know the domains of the original functions. So since they are rational functions, we need to remember that the denominator should never be a 0. Let's solve the equation denominator equals to 0 and find out which x's we should exclude from the domain of each of those functions, both the f and the g. So I'm going to take the first denominator, 1 minus 9x, and make it equal to 0. Well, this just gives me x equals to 1/9. And it does say equals to, but it really means it's not equal to 1/9, because if x is 1 over 9, then the denominator turns into a 0. We'll exclude this value from the domain of f. We're going to do the same with g. G is simple. X equals 0 is the denominator. And again, while it says equals 0, it really means that x should not equal to 0, because otherwise g will become undefined and we don't want for that to happen. Okay, so now let's find the composition. We will first find the composition of f with g. To do that, I will replace x inside of f with the entire function g. So, in place of x here, I will now have 1 over x. This x will go, and in place of x, I will write 1 over x. So the rest will stay. 5 over 1 minus 9. And again, it used to be x, but now it's 1 over x. Well, this looks a little bit complicated. Let's simplify it somewhat. So I will just work with the denominator. So in the denominator, you have this 1 minus 9 times 1 over x, and 9 times 1 over x is 9 over x. So that's 5 over 1 minus 9 over x. And then I would like to put the 1 and the 9 over x together into one fraction. So I'll need a common denominator. I'll place 1 over 1. And then I will multiply this one by x and this one by x so that they match, the denominators match. Okay, so instead of 1 over 1 minus 9 over x, I now have x over x minus 9 over x. So the denominator is now x minus 9 all over x. So the next thing to do to simplify this a little bit more, because this is still a three-story fraction, is I will have this 5 separately. And then instead of this fraction line, I will write divided by. And then this denominator as a separate fraction, x minus 9 over x. Okay, now how do we divide a number by a fraction? Well, we do keep, change, flip. So I'll place 5 over 1, keep that as is, but instead of dividing by x minus 9 over x, I will actually multiply by x over x minus 9. So 5 over 1 times x over x minus 9. And here is my final composition of f with g. 5 times x at the top, which is 5x, and 1 times x minus 9 at the bottom, which is x minus 9. So it's 5x over x minus 9. We're done finding the composition, now we need to find the domain. Let's first find the domain of the composition. The composition is also a fraction, and we know that the only restriction we place on fractions is that we shouldn't have the denominator equal to 0. In the denominator here, I have x minus 9. So to find out what x should not be, I'll say x minus 9 equals 0, which means x is equal to 9 and really is not equal to 9. Okay, so that's the domain of f composed with g. And to finalize the domain of the composition, I need to put this domain together with the domain of the second function in composition, which was g. Now remember, the domain of g was x is not equal to 0. So this and this domain have to be placed together, which means x cannot be equal to 9 and x cannot be equal to 0. And here's how you would write it in interval notation, excluding both of those numbers from the domain. You'll say we start at negative infinity until we hit 0, because that's our first restriction, x is not 0. Then we pick up again at 0 until we hit 9. And then we pick up again at 9 until we hit positive infinity. This is the domain of the composition of f with g in the interval notation. And let's now find the opposite composition, g with f. Okay, so now my base function is g, it's not f anymore, and I will be taking this function g and replacing x inside of function g with the entire function f. So x will turn into 5 over 1 minus 9x. Okay, the rest will stay, so it's 1 over, and then in place of x, I'll write this entire function, 5 all over 1 minus 9x. Well, we just looked at how to simplify this three-story fraction. I will keep 1 as is, and then instead of divided by here, I will actually write divided by, and then my second fraction, which is 5 over 1 minus 9x. And then again, we do keep, change, flip, so it's 1 over 1 times 1 minus 9x all over 5. Boy, this is loud. Okay. So it's going to be 1 minus 9x over 5. Okay, so let's look at the domain now. What is the domain of this function? Well, this looks like a rational function, but it's not. It's actually a linear function because there is no x in the denominator. It's just a 5. So this function doesn't have any restrictions on it. However, the second function in this composition f actually had a restriction. X could not be equal to 1 over 9. So combining these two together, no restriction here, and then x should not be 1 over 9, we write the domain of this composition in interval notation as follows. Start at negative infinity, stop at positive 1 over 9, pick up again right after positive 1 over 9 and go to positive infinity. So now this is the question I will ask you to do the opposite, meaning it gives you the composition, gives you one of the functions, and it asks you to find the second function. So do the backwards operation, decompose the composition. Okay, So let's look at our composition. Inside of the composition, you have the 7x plus 5 in parentheses, and it's raised to the power of 7. Now, what else is given to us is that g of x here, one of the functions in the composition, in fact, the second function, the one that was inserted into the first function, is 7x plus 5. So it looks like what happened is when the composition was calculated, they took function 7x plus 5, placed it inside of that original function, f, and raised it to the power of 7. So it appears to me that it used to have x in place of 7x plus 5, that was raised to the power of 7, and then they took function g and replaced that x with this function. So f of x has to be x to the power of 7. You can check. You can try to find the composition of f with g, meaning replace x inside of f with g. So if you take this g and place it here, removing the x, that will be 7x plus 5 to the power of 7. We're done.